The error message fatal error allowed memory size of 8,388,608 bytes exhausted. Tried to allocate 92,160 bytes in /for/www/include/classmail. PHP Online 243 signifies that a PHP script has attempted to use more memory than the server's PHP configuration allows. In this particular instance, the script tried to allocate 92,160 bytes of memory, but it exceeded the configured limit of 8,388,608 bytes. This limit is in place to prevent scripts from consuming excessive server resources, potentially impacting the performance of other websites or applications hosted on the same server. The error occurring in the class mail PHP file suggests that the problem is related to sending emails or processing email-related data. This could arise from sending large attachments, handling numerous recipients, or dealing with complex email templates. Several factors can contribute to PHP memory exhaustion. Firstly, inefficient code within the PHP script can lead to excessive memory usage. Secondly, large datasets being processed, such as extensive database queries or large file uploads, can consume significant memory. Thirdly, an inadequate PHP memory limit setting in the server's configuration can restrict the amount of memory available to PHP script. To address this issue, several steps can be taken. Firstly, optimize the PHP code to reduce memory consumption by identifying and resolving memory leaks, using more efficient algorithms, and minimizing unnecessary data storage. Secondly, increase the PHP memory limit in the server's configuration file, PHP. Locate the line memory limit and increase the value to a higher amount, such as 128 megabytes or 256 megabytes. This provides more memory for PHP scripts to operate. Thirdly, implement pagination or batch processing to handle large datasets in smaller chunks, reducing memory usage. Fourthly, review and optimize database queries to minimize the amount of data retrieved. Fifthly, ensure that any third-party libraries or plugins used in the PHP script are up to date and optimized for memory usage. When increasing the PHP memory limit, it's important to consider the server's overall resources and avoid setting excessively high limits that could negatively impact performance. Monitor the server's memory usage after making changes to the PHP memory limit to ensure that it remains within acceptable levels. If the error persists after implementing these steps, it may be necessary to further investigate the PHP code and identify specific areas that are contributing to excessive memory usage. Profiling tools can be used to identify memory bottlenecks and optimize code accordingly. In some cases, it may be necessary to rewrite parts of the code or use alternative approaches to reduce memory consumption. Working with a qualified PHP developer can provide valuable assistance in diagnosing and resolving memory-related issues. They can analyze the code, identify performance bottlenecks, and recommend appropriate solutions. If the problem is occurring on a shared hosting environment, contacting the hosting provider for assistance is recommended. They may be able to adjust the PHP memory limit or provide insights into the cause of the error. The hosting provider may also have specific recommendations for optimizing PHP code and reducing memory usage on their platform. It is also important to note that the location of the PHP .ini file can vary depending on the server configuration and operating system. Consult the server documentation or contact the hosting provider for information on the location of the PHP .ini file. Furthermore, restarting the web server after making changes to the PHP .ini file is crucial for the changes to take effect. The web server needs to reload the configuration file to apply the new settings. The specific command to restart the web server depends on the operating system and web server software being used. If the error is specifically related to the class mail PHP file, it is recommended to examine the code within this file for potential memory leaks or inefficient algorithms. Pay particular attention to sections of the code that handle large email attachments, recipient lists, or complex email templates. Optimizing these sections of the code can significantly reduce memory usage. Consider using techniques such as streaming large files instead of loading them into memory all at once. Also, using efficient data structures and algorithms for managing recipient lists can minimize memory consumption. In addition to optimizing the PHP code, consider using a dedicated email sending service instead of relying on the server's built-in mail function. Email sending services are specifically designed to handle large volumes of email and can often provide better performance and reliability. They also typically have built-in mechanisms for managing bounces and spam complaints, which can improve email deliverability. If using a dedicated email sending service, integrate it into the PHP application using the service's API or a suitable library. This involves making changes to the PHP code to use the email sending service's functions instead of the built-in mail function. Follow the documentation provided by the email sending service to ensure proper integration. It is also important to regularly monitor the server's performance and resource usage to identify potential issues before they escalate. Use monitoring tools to track CPU usage, memory usage, and disk I/O. Set up alerts to notify when resource usage exceeds predefined thresholds. This allows for proactive intervention and prevents performance problems from impacting users. If using a content management system, CMS, such as WordPress or Drupal, ensure that all plugins and themes are up to date. Outdated plugins and themes can often contain security vulnerabilities or performance issues that can contribute to memory exhaustion. Regularly check for updates and install them promptly. Before updating plugins or themes, create a backup of the website to ensure that data can be restored in case of any problems. It is also a good practice to test updates on a staging environment before applying them to the live website. This allows for identifying and resolving any compatibility issues or conflicts before they affect users. If the website is using a caching plugin, configure it properly to optimize performance and reduce server load. Caching plugins can store frequently accessed data in memory or on disk, reducing the need to regenerate it for each request. This can significantly improve website performance and reduce memory usage. Experiment with different caching settings to find the optimal configuration for the website. It is also important to ensure that the caching plugin is compatible with the PHP version and other plugins being used. In addition to caching plugins, consider using a content delivery network, CDN, to distribute website assets to multiple servers around the world. CDN can reduce the load on the origin server by serving static content such as images, CSS files, and JavaScript files from geographically closer servers. This can improve website performance and reduce memory usage on the origin server. Choose a CDN provider that has a global network and offers features such as caching, compression, and security. Integrate the CDN into the website by configuring the DNS settings and updating the website's code to use the CDN URL. If the website is using a database, optimize the database queries and schema to improve performance. Slow database queries can consume significant server resources and contribute to memory exhaustion. Use database profiling tools to identify slow queries and optimize them by adding indexes, rewriting the queries, or using caching. Review the database schema to ensure that it is properly normalized and that data types are appropriate for the data being stored. It is also important to regularly maintain the database by performing tasks such as vacuuming and analyzing tables. If the website is using a large number of images, optimize them for web use to reduce file sizes. Large images can consume significant bandwidth and increase page load times. Use image compression tools to reduce file sizes without sacrificing image quality. Consider using different image formats such as JPEG, PNG, or WebP depending on the type of image and the desired level of compression. It is also important to properly size images to fit the display area to avoid unnecessary resizing by the browser. If the website is using a large number of CSS or JavaScript files, minify and combine them to reduce the number of HTTP requests. Each HTTP request adds overhead to the page load process. Minifying CSS and JavaScript files removes unnecessary characters such as whitespace and comments, reducing file sizes. Combining CSS and JavaScript files reduces the number of HTTP requests required to load the page. Use tools such as online minifiers or build tools to automate the minification and combination process. It is also important to consider the server hardware and infrastructure. If the server is under-resourced, it may not be able to handle the traffic and workload of the website. Consider upgrading the server hardware to provide more CPU, memory, and disk/IO. Also, ensure that the server is properly configured and optimized for performance. Consider using a solid-state drive (SSD) for the server's storage to improve disk/IO performance. If the website is experiencing high traffic, consider using a load balancer to distribute the traffic across multiple servers. Load balancing can improve website performance and scalability by preventing any single server from becoming overloaded. Choose a load balancer that is appropriate for the website's architecture and traffic patterns. Configure the load balancer to distribute traffic evenly across the servers. If the website is using a microservices architecture, ensure that each microservice is properly resourced and optimized for performance. Microservices can introduce complexity and overhead if they are not properly managed. Monitor the performance of each microservice and identify any bottlenecks or performance issues. Use appropriate monitoring tools and logging to track the performance of each microservice. Consider using containerization technologies such as Docker to improve the portability and scalability of microservices. If the website is using a message queue, ensure that the message queue is properly configured and optimized for performance. Message queues can be used to decouple different parts of the application and improve scalability. Monitor the performance of the message queue and identify any bottlenecks or performance issues. Use appropriate monitoring tools and logging to track the performance of the message queue. Consider using a distributed message queue such as Apache Kafka to improve scalability and reliability. If the website is using a NoSQL database, ensure that the database is properly configured and optimized for performance. NoSQL databases can provide high performance and scalability for certain types of data. Monitor the performance of the NoSQL database and identify any bottlenecks or performance issues. Use appropriate monitoring tools and logging to track the performance of the NoSQL database. Consider using a caching layer in front of the NoSQL database to improve performance.